Okay, hi, we're going to talk about the inverse circular function of cosine now this time. And what I want to point out to here again is much like the sine inverse circular function, we do the same kind of explanation. So what I have here is I've got drawn up the cosinal wave, and that's all of its inputs and outputs, and that is that cosine of x, this is the cosine of x, is equivalent to y, so written as y as a function of x. And the inverse would be writing x as a function of y. So what we have going on here is when I begin to take a look at this, I want to see basically when does the inverse occur, and is there any times is the period the same as is the domain the same as the sines. So here we go. So basically what I do is I invert this graph here, and what I find here is that when I draw the vertical line test on this one, that it proves yes, it is a function. But if I were to do it here, you would find that as I draw the line going down, it breaks it and it goes through it multiple times. So what we have here is we're going to center around 0 and say, you know, get a function to exist as close to 0 as possible. And what you find here is that the function exists. If I went to the negative, well, if I take the opposite value on the negative side here, that it goes through that point, so that kind of takes it off. So what happens here is we end up chopping this one off at pi, okay, because that's when this function here, when I turn it off on its side, that this, if I do the vertical line test through, you see it only passes through once, continue using the same line here once. So what we say about the domain of the cosine inverse is that the inverse exists only on the domain of 0, which is less than or equal to the x, which is less than or equal to the pi. So the significance of that, it deals with quadrants of your angles and the signs of your values. So here we go. What we're going to take a look at here is the arc cosine of root 3 over 2, and how is that I would calculate that. And this all goes back to, we've learned the cosine of 30, the cosine of 45, cosine of 60, cosine of 90, cosine of 0, and what their outputs would be. So what I'm going to take a look at here now is basically taking this and applying that this really is the same as this up here. So all I'm doing is that this is the y, okay? So all I did really was replace the x and the y, because if I take the cosine of this, then I'm left with this, and if I take the inverse cosine, the cosine of the arc cosine, that leaves me with just the value inside. So here we go, and that's what I'm going to do, and that's how I'm going to apply. So this side here, if I took the cosine of it, okay, that leaves me just with root 3 over 2, because these two cancel each other out, and I'm left with cosine of x. So what I'm now looking for is the cosine of what angle gives you an output of root 3 over 2, and the cosine of 30 degrees is what gives you the output of root 3 over 2. Now you have to be careful, because sometimes you have real answers and you've got degree answers. If someone asks you what is the real answer, well, x in real value is with pi over 6, which is the same thing as 30 degrees. So that's how you do that. So this was with a positive. So let's say now that I changed that and made that to a negative. So let's say if I changed this, just the value inside there, and made that negative. Well, this comes into play with the quadrant. The positive one doesn't really play a role, because it's positive, that it's always in the first quadrant. So what we're going to now look at is how does it change the effect of it if I put it a negative with it. And it's the same exact process. I take cosine, so I left all the work there, and except this time I'm left with negative root 3 over 2 is equivalent to the cosine of x. So now what I have to look at is, where is cosine negative? Well, cosine is negative in quadrant 2 and in quadrant 3. But if I take a look back at this graph, the inverse doesn't exist outside of quadrant 1 and 2, so what my answer is has to be an angle measurement that goes from quadrant 1 into quadrant 2. So this is when we use the reference angle, and the reference angle is an angle measured from the x-axis. So in this case here, while cosine of x, root 3 over 2, is 30 degrees, the reference angle in the second, okay, that 30 degrees, remember it's always measured from the x-axis going counterclockwise, is that this would be 180 minus 30, which is 150 degrees. So taking a look at this, I find that the cosine of negative root 3 over 2 is when x is equivalent to, in this case, 150 degrees. And now I can't use the idea of the negative angle because the rotation, as you saw for sine, went down or it went up. So in this case, I have 150 degrees, or because it's 30 pi over 6, so pi minus pi over 6 is 5 pi over 6. And those are my two answers that I can use for cosine. So I hope that helps, and I hope you understand the inverse function of cosine a little bit better.